I'm very excited here to talk about how 200 plus business leaders on how they made their data work harder than their people. And this is really what it's about. It's about you're here because you're interested in data engineering or are a data engineer yourself. And by that, I mean that at some point, or maybe even now, like literally physically right now, you're probably building a report or data pipelines in the service of business users, in the service of business goals. And sometimes that's exciting, and other times you find yourself wanting to do more high leverage work. And my challenge is, how can I make your life better in the next 30 minutes? Something that I realized through my experiences at Instabase and Trifacta was that a lot of the mundane parts of data engineering comes from operational business workflows. Some examples of that are your business user needs that daily report on how many customer support tickets are over 24 hours old, or the sales team wants you to combine Mixpanel and Salesforce data to get a list of product qualified leads for the day. So actually talking to these business users and trying to understand their needs is a key part in making your life easier. In the last year, my team, forgot to advance the slide. In the last year, my team and I have interviewed around 200 leaders from Square, Stripe, Airbnb, Oscar Health, Grab, Pinterest, DoorDash, about their operational workflows. And this talk is the result of a lot of raw, boots on the ground conversations. So not really data you'd find by Googling around that much. And we asked these business leaders three main things: how they were using or wanted to use data to achieve their goals, what challenges they were facing in doing that, and how their companies were thinking about solving those challenges for them. And our results revealed a few key things. So the first thing I'm going to talk about is the needs. There was a high correlation between how successful the company was and how empowered the business people felt, not just to see their data, but also to take actions on it without waiting for engineers. So we're going to go into why this is important, but if there's only one thing you take away from this talk, it's if you want to live a better life as a data engineer, let your business users self-serve. The second part of it was, how did data engineers come up with a system for solving these problems? A lot of these companies had spent enormous amounts of engineering resources on building and maintaining internal tools that let business people self-serve. I'm going to show you what an end-to-end user experience for that looks like, and also a reference architecture for if you were building something like that, how would you build that yourself? And lastly, there was a lot of emphasis on you might have all of the best tooling, but you're not going to get the most value out of it unless you know how to use the right tool at the right time. So we're going to go into a little bit of when should you use dashboards versus alerts versus reports versus tickets. And we also picked up a few best practices that we'll share on how people use these systems. And finally, I'll share some case studies that are public, some that are not, and how these companies have driven results through that. Who am I? If you remember one thing from this slide, I live at the intersection of data and business operations. And as Kashish said, I am the founder of LogicLoop. And disclaimer, a lot of these interviews were our due diligence in the founding of this company. And what we do at LogicLoop is help companies, high-growing companies, scale faster by letting business users actually take actions on the data. But what we realized was all of the learnings that we had in founding this company are really not limited to the product, and they're worth sharing with the general population. And before that, I was a founding engineer at Instabase, and we were helping large Fortune 50 companies automate loan and insurance claims operations. And before that, built data transformation software at Trifacta. So if you've used Data Wrangler or Google Dataprep, Google Cloud Dataprep, you may have run into a bug that I caused. Okay, so let's first talk about the problem we're trying to solve here. So what problem were these business leaders trying to solve? Something we heard immediately was that companies felt that the analytics and ML AI stacks were almost further along than their raw, basic operational data stack. And you might ask what operational data means. We'll go into that in a second. And the biggest thing here was that sometimes it was easier to actually work on the harder things because more people wanted to work on the hard things. And that meant that a lot of the basic operational workflows didn't get as much data attention. Operations data is everywhere. So the common thread amongst this kind of data is that it's directly related to the value that the company is providing. So for fintechs, operations means originating, servicing loans, facilitating transactions, preventing fraud. For logistics, operations means having the right level of inventory, managing order expectations. For healthcare, it's about delivering timely care in a cost-effective manner to patients. And since operations is really at the core unit of work that a company does, operations data is used to facilitate this fundamental value creation at a company. What does that mean? So the data has to come from somewhere, and you'd expect that clean operational data lives in warehouses. That's a great, great dream to have. But the reality is that sometimes not all data can be in warehouses because data pipelines take longer to run than the freshness of the data that you need. Enter production databases. Now, sometimes operations people need to be able to change values on the fly, and they don't have right access to databases. Enter Google Sheets. Sometimes you're using a bunch of different SaaS applications like Mixpanel, Salesforce, whatnot, to manage actions, and those become systems of record. So enter all of those SaaS apps. And then lastly, depending on the industry you're in, you might actually try to supplement your internal data with external data, so you're constantly relying on external data APIs. And coming back to that first part of the need, business leaders need a system that can read from any of these data sources so that they're able to make timely decisions on their data. What happens after decision? Particularly for operational data, you have to translate that decision into actions. And actions can take a variety of forms again. It could be a Slack notification, something like, the price of gas went up today and your delivery margin is going to go down. It could be an email. Here are all the transactions you did this week. It could be a ticket. Please review Jesika Harya's account for fraudulent activity. It could be triggering things in internal or external systems, even writing feature tables back to databases. And business users need a system that can allow them to take these kinds of actions in a controlled manner. So what we just saw was operations data comes from many places and goes to many places. And how familiar are you with some kind of exchange like this, where Ollie, the ops person, needs something to happen right now, and you, Danny, the data engineer, is like, actually, no, can we do this next sprint? And for some cases like fraud, this would actually kill companies because you can't wait for 2 weeks to fight fraud that's happening today. The fastest growing companies we found actually have the most friction around this kind of operations. And why is that? It's because growth comes with new pressures, comes with new apps being used, new people being hired, new workflows, new products being added all the time. And all of this creates a demand for clean operational data, which is a demand for good data pipelines. But only about 20% of the engineering requests amongst the interviews we did were actually fulfilled by data engineers. So the question is, what do we do about the 80%? And that is really the core of the business user's problem. It's simply that 80% of the data needs go unmet. Okay, so how do we translate that problem into a statement that we can actually do something about? Here's a handy formula for how you can think about this. So the amount of work you have to do increases as your data increases and as there's more growth pressure on your company. Neither of those are going away. It decreases if you have more engineers, but engineers are really hard to hire. We all know that. So the only lever you truly have in making your life easier is how you can self-serve systems for business users trying to accomplish basic tasks. It's also the best way for you to free yourself up to do high-leverage tasks and progress in your career. And the winning companies of the future will let their business users do a lot more than they can do today. I didn't make this law, I'm just the messenger. There's a quick something for you to ponder on as you think about yourself and your company. This is a quick operations data maturity checklist where your business should be able to read, write, and leverage data. What does this mean? Reading data. Does clean operational data exist? Does business know where to find it? And can business serve self-serve insights? A lot of BI tools are serving this need. The right need is, can business users proactively identify issues, debug and rectify exceptions as they happen in real time? And the last piece of the need is, can business users automate handling these exceptions, and can they themselves improve their operational processes over time? So now that we know why self-serve is important, let's talk about the what and the how. In this section, I'm going to talk about the business user experience as told to us by interviewees, about what they'd like to see, how they'd like to interact with systems like that, and a reference architecture of how you can build a system that facilitates this self-service. So again, just to be clear, some of the motivating use cases here are, you might want to trigger a Slack alert when a large transaction happens. You might want to set a text reminder for users to pay up. You might want to automate weekly account summary emails. And in all of these cases, you're triggering an action when a certain condition is true on your data. One of the big debates that people have when thinking about an ideal business user experience is SQL versus DSL. That's something that we lived a lot at Trifacta, and we went the DSL route. And in an ideal scenario, your business user is not entirely non-technical. So they're actually semi-technical business users. Amongst the companies we spoke to, the best-of-breed companies like Stripe and Airbnb actually did SQL trainings for their business users, for their operations analysts, for their risks analysts. So they actually could go in and do more things with their data themselves. And also, we scraped about 1,000+ jobs on what operations roles needs these days. And about 39% of them required or desired SQL as a skill. So that's definitely something on the rise. And this experience assumes that you choose the SQL route. That's something that we did because we think that SQL is the lingua franca of data. Now, with these data skills, a semi-technical user can come in and write a query on top of Snowflake, one query on top of Google Sheets, and another on top of a Salesforce API. They can write a fourth query that actually combines data from all of these places as if it was on one database. And they would then configure, using all of this data, to configure a Slack alert, to configure an Asana ticket, to configure the contents of the text message. And the shift that's happening here is that the business user is moving from dependence on engineering to greater independence. They're able to specify these workflows themselves. And from a pull-based mentality, let me keep checking this dashboard every 5 hours, to a push-based mentality where the data will tell you when something fails. And consequently, you as the data engineer also need to make a mental shift. Your goal is not to necessarily build every single one of these pipelines, but it's to build a platform that lets business users self-serve these pipelines themselves. Of course, I have to caveat this with, if it's something that's very mission critical, you still need to be involved, you still need to be writing these data pipelines, but this is for that long tail that's not worth your time to actually solve. And what an example of a solution could look like for this is, this is something that we've been doing internally. I'm sure there's many alternative, just as valid solutions, but one example of how this could work under the hood is Ollie, the ops person, wants to read from Postgres and write to Slack or Zendesk or email. And what they do is they send a request to your web server, you interact with a user interface, they send a request to that web server, and that web server actually then, under the hood, there's two different workers. One worker is the query worker that just runs the queries, And the second worker is an action worker that actually takes the actions on the data. And you want those to be separate because one, it's actually easier to scale them independently if they remain separate. And two, you don't necessarily want your query worker, which has access to all of your internal data, to also be on the same machine or be the same worker as the actions worker, which is actually triggering a lot of things in external systems. So what happens is your request goes to the web server. The query worker picks it up, runs the query against your Postgres database, writes out data to your internal database, and posts a job for the action worker to come and pick it up, read results from the database, and then take actions. Simple enough. And now, how do we extend that to a scenario where you want to combine data from a Google Sheet and your internal database? So Ollie, the ops person, writes query 1 on the database. Query 2 references a Google Sheet. And query 3 combines the Google Sheet with the database as if it were in the same instance. So that's how magical the experience is for them. And under the hood, what's happening is that your query worker is running query 1 and query 2, and it's writing the results out to the database, but also creating a temporary in-memory database. So we actually use SQLite for this, where you create a temporary in-memory database that you then run query 3 on. So from the user's perspective, it was always kind of in one place. But from our perspective, we're creating these things on the fly and on a per query level. Again, this will not scale where the data is large, but it will scale where there's a need for speed, so you actually can afford to build a whole data pipeline, and when the data is medium size. For a lot of operational workflows, that does tend to be the case. And then the query worker does its usual thing, writes back to the database, posts a job in the job queue, action worker picks it up as normal. But this was one of the architectures we found that was really simple and yet super effective. It had an outsized impact on what business users could do as a result of something like that, without us having to build it every single time. So there's a common pattern among the best internal tools we found at these companies. It's select data, write business rules, trigger actions. And this is a system for business users to detect and act really, really quickly. Now, say you built this system, or you have this system, or you have a partial solution to it. The journey actually doesn't stop there, because a lot of what you get out of it depends on how your business users and how your organization just uses the tools that are available to them. So we picked up some good best practices along the way on how companies got the most out of these systems as well. The first thing that's really, really important, I realize it might be a little bit unclear there, is route your data correctly. And the best companies had a good philosophy, a good set of operating principles for the right tools to do the right jobs. And so far, we've been talking about taking actions on data, but this also applies to more informational use cases. So I'll drive this point home with an example of, say, we're tasked with fraud data operations. So let's think about, what is our main purpose right now? Are we trying to just know things about it, or are we trying to do things about it? So if you just want to know something about it, ask yourself, do I need this knowledge to be interactive? If I don't, put it into a report. So an example of a report could be a daily losses summary report, and that's a great example of what should actually go into a report, where someone just needs an understanding of the top numbers that fit in their brain. If you do need it to be interactive, dashboards are a great way of doing that. And a common case is transaction monitoring dashboards, where business users are able to come in, enter a customer ID or transaction ID, and get the information they need about that particular event. So that needs more interaction. Now, if you're actually trying to do something about an operational trigger or a data trigger, ask yourself, do humans need to be involved? If they don't need to be involved, stick it into an automation. So you can auto-reject transactions that come from this particular IP address that you know are bad. No human should actually be doing that at your company if you know exactly what needs to be done. And if humans do need to be involved, ask yourself, is it urgent or is it not urgent? And this is where I think a lot of companies struggle the most, is the urgency is not quite clear, and things go into the wrong buckets. So a good heuristic here is, if it's a normal course of action, if someone needs to just review things, create a ticket about it. And it could be in Slack. You could create your tickets and manage your tickets in Slack, but the expectation is not to treat it like an alert, because if you do, then you'll miss all of the things that are actually going wrong. So here, an example of a good ticket is reviewing large transactions. They're coming in, you're reviewing them, and approving, rejecting them. And the last piece of it is if it's urgent, such as an unusual spike in losses or whatnot, then you need to have a good system around detecting and escalating. And a lot of times there's a few symptoms that come up in companies when this isn't working quite right. So if you are finding yourself refreshing dashboards very often, then ask yourself, do I just need to know a single number often? Or am I waiting for a data condition to be triggered such that I can do something about it? So if you just want to know something, stick it into a report, have it send you an email or something. And if you're looking for a specific data trigger, refreshing dashboards isn't the right way to go about it. Actually set up that trigger. And an analogy is, if I'm going to bed and I want to wake up at 9 a.m., I don't check my phone at 1 a.m., 2 a.m., 3 a.m. I just set an alarm for 9 a.m., and the system lets me know when those data conditions have been met. Another case where we've seen a lot of companies fail is too many alerts. They're getting paged. If you're getting paged more than 5 times a week, it shouldn't really be an escalation situation. It should either go into a ticket if it's normal course of business, or you should actually be investing more in reliability, not monitoring. So that's something to think about. And then if you're performing the same actions over and over again, try to see if you can automate it. I'm not saying something that you don't know already, but you would be surprised how many workflows in companies we interviewed triggered a Slack alert for a customer success person to send an email to someone with a template. That is the exact definition of a thing that can be automated and should be automated, and that the business users should have the agency to automate themselves. All right, so the next section is just a deep dive into some alerting and just general best practices we saw. First, in terms of creation, don't re-alert for the same issue. Again, this is a real problem that even LogicLoop has. Calibrate as early and as often as possible, and aim to keep the volume on true escalations low. We'll go into content in just a second, but these tips can be useful either for alerts or for tickets. It can be really valuable to have a good, well-written alert or ticket. Saves a lot of time when you're under pressure. And the last piece is think about how the whole is greater than the sum of the parts. You have all of these things happening on top of your data. Let them not be strangers to each other. So your alerts should work in cohesion with each other. And this is one of the companies that we spoke to, actually. They were sending out 20 emails per day to a certain cohort of customers without realizing what was going on, because there were so many different systems that were sending out emails. So try not to miss the forest for the trees here. And one example of how you can improve the content of an alert or a ticket here is by adding a few key pieces of information. So what you see here is there's a system of origin, there's a clear owner, it's skimmable, there's a link to more details, there's some relevant info, there is an understanding of how important, how urgent it is. In this case, it's pretty bad because it's 150x of what you would normally expect. There's a call to action. If you can do that within the alert itself, that's great. And there's a reminder on the SLA and the risk level here. And you can go even further and add notions of volume. This is the 5th alert that fired this month. And this is an example of one of those things that might take you 2 minutes to go through your Slack channels and notifications or your alerts and really understand, can I provide a much better experience to either myself or my teammates and save them time? So if you save someone time, but just adding a link to something in here or adding a piece of data in here that they don't have to click that link for, and if they're seeing that Slack message 10 times a day, you're saving them 2,000 minutes a year. So this is a really good ROI on simple changes that have outsized impact. And the last thing is that none of these systems should be static. encourage you to think about how they're always improving over time. Some of these things, honestly, these companies that we talk to have taken years and years to actually perfect these systems. The biggest thing is improving the signal-to-noise ratio. Running regular analyses to weed out alerts that have more than X% false positive rate, or consolidate alerts that have more than X% overlap between them. And also one really important thing is to be able to distinguish between no data and data that's supposed to be there and isn't. And a lot of times it's not clear where the issue is or how far down the stack the actual issue is. A lot of what makes these systems also work at scale amongst a large group of users is if you can treat alerting even business user logic as code. Version control, backtesting, permissioning, approval processes, all of those are things we expect from code, and we should certainly expect that from operational processes, not in code as well. And in terms of the management, there's a whole human side of actually managing this entire system. You want to make sure that every time you have notifications or alerts or escalations, you have the commensurate amount of staffing. So someone's actually taking a look at it. It's not going into the ether. Someone can groom backlogs every month. That's been really effective. And you should ideally also be tracking the amount of time it takes to resolve certain tickets if you're doing it manually, and understand whether there's an opportunity for automation. And the last thing is an opportunity to also consolidate decisioning systems wherever possible. This is the kind of stuff that needs kind of a constant looking into every 6 months to a year. And one example of how companies have typically built up these over time is, again, I'm going to continue with the fraud example. You might start off by just adding a Slack notification every time a large transaction happens. Then, as you get more data, you would adjust the thresholds. Once you start getting too many Slack notifications, then you start putting them into a review and ticketing system. And then finally, once you have enough confidence about your process, then you can think about auto-rejecting. So there's a ladder there of operational maturity that any new process has to climb. And the challenge your system will face is how can it be modular and help the business user rip and replace parts of it as they become more operationally mature. So just as a summary, what we just talked about is we can route data correctly, and that we know that it's important to do that. I shared a little bit of a decision tree. There was a little bit of a deep dive into alerting best practices, or checklists, some examples, and then some stuff around iteration with, again, another checklist and an example of a ladder that you could follow. And the final section of this is, you don't have to believe me. There is a lot of public documentation on what some of the largest tech companies we know have done. So the first case study is Oscar Health. They're a healthcare insurance provider. And you'd ask yourself, what is a healthcare company doing building all of these systems? But they have a lot of operations needs, and their core business is in furthering how better you can deliver healthcare with technology. So they built this thing called Automat, which is a self-service configuration platform. And Automat hooks into all of Oscar Health's data sets. So from providers to claims to in-app messaging to brokers. And then it allows semi-technical users from business teams to create their own triggers. They call them recipes that then generate actions. So it creates an internal task. It would send an external secure message or an email. And Automat, the way their user interface was they used the YAML format, where people eventually picked that up over time. And today, Automat powers about half of their internal processes at Oscar. Uber is another example of a company that built Mastermind. You might be already familiar with it in a different context for fraud rules. So Uber was having this problem around there's a lot of fraud, there's a lot of promotions, there's waste, there's abuse, there's a lot of different flavors of it. And someone I spoke to there actually said that the models were getting outdated every single week. And they realized that it was not tenable for an engineer to come in and code up a response to an active fraud attack that was happening. In their case, they said it took the engineer about an hour to implement a new change to their system, which honestly I think is really fast. Most companies we spoke to took 2 to 3 weeks for a new feature to be implemented into their risk decisioning system. And what they did instead was they actually had, they built a very similar kind of rules engine that their risk analysts to come in and within a matter of minutes, implement a change that affects all of Uber's fraud rules. All right, cool. And some of the case studies that aren't public, that are anonymized, that came up in some of our interviews, were that there was this one very large fintech payments processor company where they built out a similar internal tool, and it started off with risk analysts just triggering Slack alerts on data. That's how narrow it started off. And eventually, it was used by 40% of all employees across sales, across marketing. So risk started off writing, show me all transactions over $100,000 and send me a Slack alert about it. Sales came in and said, show me all users that are using 80% of their credit limit and send them an upsell email. And that ballooned in its use cases. And at some point, one of the risk analysts we spoke to was saving the company millions of dollars per quarter with just the fraud rules that he was writing without having to touch code. That's a lot of ROI right there. Another Series B fintech we spoke with realized very quickly that a lot of their revenues, they were in the process of giving loans out to immigrants. And they realized that a lot of repeat loan takers were actually really good customers. If they were able to fulfill their loan the first time and repay it, then they would actually be able to do it the second time. And they already trusted the company to do that. And they wrote about 8 rules. The head of credit risk and analytics there wrote about 8 rules, again, without having to touch the code, that retargets existing loan holders that are proving out good. And now that business line is 40% of their revenue today. And that all started off because he had the ability to experiment with these kinds of rules and these retargeting messages himself. There's a recruiting company that got a 32x ROI they wrote one rule to send out an account summary email. So their customers were companies like ours that are trying to recruit, and they would send out a summary email to their hiring managers talking about the pipeline and about the impact that that company was having. And that itself led to a 32x ROI because previously their customer success team was doing it manually, going into the database, writing a query, downloading the CSV, formatting a table in an HTML page within an email, and they were able to automate all of that. And then finally, a Series C fintech realized that they had a lot of issues with alerts that were duplicates of each other. So they were actually the engineering team was able to add a single deduping feature that saved them 2 months over the next 12 months of all of the stuff that they would have to write deduping logic for instead. Cool. So we're at the end. In summary, what we talked about is 200 plus leaders, operations needs, and the need is simple, self-serve, and we have a little maturity checklist that you saw. We also talked about a system for business alerting and automation in terms of what it could look like on the user side, and a very simple example of how you could power it. And we also talked about how you could get the most out of these systems or any systems like this, and some examples and case studies of impact. I find this stuff very exciting. I think about it all day. So if you want to chat, let's continue the conversation. If you want to build it out yourself, happy to chat about that. If you don't, happy to do that as well. Thank you.